Okay, well, let me get started then. My talk is deep dive into building streaming apps with Apache Pulsar. I wish I was on the beach, but I guess the code will be. I'm a developer advocate at Stream Native. I've been at Cloudera, Hortonworks, Ernst& Young, Pivotal, HP, a bunch of different places covering different kinds of streaming and messaging technologies. Right now, I've been focusing on what I call the flippin' stack, which is Flink, Pulsar, and Apache NiFi, all open source, to build a bunch of different batch and streaming projects, whether it's CDC, IoT, lots of different things, including all the different cloud sets that you need to run on and AI. Every week I have a newsletter. You'll get these slides. So if you're interested in those, you can check it out. But what is Pulsar? It's kind of the main feature of what we're talking about today. It's a little different from some of the other streaming tech, as it was designed cloud first, designed to be cloud native, to do messaging and event streaming in one platform. And a couple of the features that make it perfect for this. One is one messaging platform to do everything. You don't need to install a couple of different products or projects. One open source platform to do all the major types of messaging. We guarantee you get your messages. System is very resilient, designed to handle multiple servers failing, multiple pieces of the technology going down, and then being as scalable as possible, again, with that cloud native infrastructure. There's companies in China running tens of thousands of nodes of Pulsar, petabytes of data with no issues. So scale from a single standalone node, maybe running on your desktop or on a Raspberry Pi, and then scale up to thousands of nodes, millions of events per second, as big as you need to go. A lot of different applications you could build on the platform, microservices, real-time apps. Nice feature here is tiered storage is built in. So when you get to a certain size, it'll automatically start putting it into, say, S3 buckets or ADLS2. Depends on how you want to set that up. That way you could save yourself money. Everything is asynchronous, so you don't get stuck waiting for things to complete. There's caching and some other features you can put in there if you don't want it to be as async. Very resilient, designed for pieces of it to go down. And when you're in full cluster mode, very easy for you to have Kubernetes bring up new nodes and just continue going. The data isn't tied to the infrastructure except in storage. I'll get into that later, but as opposed to some other streaming systems, the messages aren't stored on the nodes that deal with consumers and producers. So you could still have those nodes go down and not lose messages, not have to reload things, not have to balance nodes. This just happens for you automatically. To say that, though, there is a slightly more advanced architecture underneath the covers because of this separation of compute and storage. So we've got the Pulsar brokers. Make sure I do all the routing, with some cache in there, does the automatic load balancing, manages topics, talks to our metadata storage to get any metadata about things, and also to discover services as they're brought into play. So as you keep adding and removing nodes for different pieces of the architecture transparently. Traditionally, this was Apache Zookeeper. It's been opened up now. Right now, we've got etcd and RocksDB as option. RocksDB is really just for the standalone one or the one you're running in Docker, just for, development. Then the part that's really different from the other messaging systems is there's a full-fledged data store that's a separate cluster, that's Apache Bookkeeper, that stores all the messages, also keeps track of everyone where they are when they're reading the messages. So as someone writing the consumer code, your app doesn't have to keep track of it for you. The server does that. So if you go down or other things go down, we know where you were, and you could go right back to where you are and resume reading messages, even if it's in a different architecture even if it's in a different client. Makes it nice. Also makes it faster for storage than having all those on that one broker. So the Pulsar brokers can be very small servers. Bookkeeper is a little heavier with maybe SSD drives. But again, with that tiered storage, when you get to a point where you're thinking you're spending too much on that storage, send that data off to S3 and it's still available in the system. You don't have to change your code. You don't have to do something to recover it, to bring it back into the system. It is available for all the consumers and clients in the system. So that's nice. Now, when we move data around, it's a message. This is pretty standard if you're doing any other kind of messaging, but just to give you an idea, we've got a raw byte payload. We've got a key, not required, but comes in handy for a lot of different things. So if you can, put a key in there. Look, you have a key value store of any properties you want to have to go along with your message. Keep the name of who made that message. Very helpful for debugging and doing deduplication if you need to have that. And a sequence ID so we know what the order is of things. Again, if you do accidentally produce duplicate messages, we can use these to make sure that those aren't propagated down the line. So I said unified messaging because we do two different things. We do message queuing. These are the traditional messaging that people did with JMS. They did it with ActiveMQ, RabbitMQ. These have been done forever, and they're still around because there's a lot of good use cases here. Things like work queues, things where you're not really concerned about ordering. You just want to push things through the system and have an asynchronous connection between who made those messages and whoever reads them. You know, it's a very useful feature to have. We also support streaming. This is the more, what people think of more modern, big data style messaging, where things come out of tables like CDC, where you've got IoT, where you want things in order. Someone's going to consume it in a specific order, and that's important. Now, besides just having ways to get data in and out via these standard libraries, there's a lot of different other options for how you connect the data, process it within Pulsar. Built in, and this is a really nice feature, is support for functions. If you're a database person, similar to triggers, these are lightweight. This is not designed to replace Spark or anything like that, but it's good for, and I'll show you my use case, breaking up messages as they arrive, maybe routing them somewhere else, maybe doing some validation, lookups, those sort of things. Support Java, Python, and Go right now, but that could be extended. Connectors, this is the times you don't want to have to write any kind of code. You configure it and say you want data to automatically come out of Postgres and get pushed into, you know, Cassandra or Scylla or something else. You just do a couple of configurations and it does it for you. And part of that unified messaging is we don't just talk Pulsar, we talk many different protocols. So I could talk AMQP, which is used by Rabbit. I could talk the Kafka protocol. I could talk MQTT used by IoT. So you can use those existing libraries. You can have those existing systems push data or pull it from Pulsar transparently. Nice way to do that. We also have first-class support for a number of engines to process the data once it's in Pulsar. Apache Flink, Apache Spark, and Presto. And I'll show you how we interact there. And as I mentioned before, that tiered storage, and that is configurable as well. So if you want to write your own, any of these are extensible. If, say, you have a cloud that's not supported or someplace you want to offload the data into maybe a proprietary SAN. Now, an important feature for messaging systems and streaming systems is to have schemas, because I mentioned just raw bytes. Hard to know what that data is, especially if I'm, you know, consuming and producing from different apps, different companies, different clouds, different parts of the world. You might not know what this data is. Having a schema makes it easy to understand what it is. Also makes it easy to describe within something that sees data as tables, such as Flink SQL, such as Spark SQL, such as Presto and Trino. So we have a built-in schema registry in Pulsar, and this will let you put your schemas in a couple of different formats. And typically these are Avro, JSON, and protobuf. They could also be string, and there's support for a couple others, again, extensible. Most people tend to stick with JSON or Avro. Makes it pretty easy. So you've got your fields, field names, types, nullable, those sort of things. It makes it very easy for you to be able to send data as bytes and have it translated on whoever's consuming it. This is nice because now you're not tied to a specific language for producers and consumers. They don't have to be the same. You don't have to know anything of the data other than how to connect to the server, what topic it is, and it'll push that schema to you, and you'll be able to consume your data very easily. Now, I mentioned those plugins for multiple protocols, and they work just like the native ones. It's not a little proxy or thing on the side. It's not some kind of half-done bolt-on. It is the same level of support as the native protocol. What this means is, you could take any app that says use Kafka, use any of those libraries to push and pull into Pulsar natively. What's nice is if I push it in with Kafka, I could pull it out with RabbitMQ AMQP, or pull it out with Pulsar, or you do both of that, or you pull it out with Spark. It doesn't matter how I got that data into Pulsar. It comes in the same way, looks like the same data. It's just if you want to pull it or push it with some other protocol, you could do that. And that includes as well MQTT. So that's nice. That one's used very often in IoT devices. Same if you want to do Rabbit. Again, this is a great way so you could unify all your messaging so you don't have to rewrite all those apps you have. New ones, yeah, I'll do them natively in Pulsar, but existing ones, just point it to a different server, runs on the same ports, has the same topic naming, makes it very easy to just pick up apps and push them somewhere else. Maybe dual ingest for a while until you turn off an older system. Great way to do that. Pulsar SQL lets me look at all the data that's sitting in those topics, and it goes right down to the storage level, super fast. And it works with the neutrino as well. And this just reads the data for me, because sometimes you don't want to have to write an app to look at your data. So I can use Pulsar SQL to do it. I can do it from command line, similar to like SQL Plus, or I could just use any of Presto's JDBC or ODBC drivers and use it in any of your SQL tools. So this gives me instant access to what's sitting in those topics. And again, with our storage nature, I could store as much data as I want. I could store it forever. So that makes a good reason why you might want to take a look at that data as it is right now with Pulsar SQL. And there's a lot of different things you could do with Pulsar. One of the nice feature is built-in georeplication. So with a simple configuration, I can push different topics between different clusters, and I could do that active-active where they trade back and forth, or I could push one way, depends how you want to do it. I could push every topic. I could put some topics. One of the nice features of Pulsar is it's multi-tenant, and I'll show you when we start looking at the topics what that looks like. And basically, I set up tenants, again, everything with full security, underneath their namespaces, and I build my topics underneath there. So you could decide, this app gets this tenant and the namespace is under it, or maybe it just gets a namespace. That way you could even have multiple companies hosted on one Pulsar cluster. And there are a couple of smaller cloud providers that do that, and that's even how they host Kafka. Pulsar functions we mentioned before. Serverless event streaming framework, very lightweight. It could run as part of the broker if you want to keep it simple, but you can also have that deployed to a Kubernetes cluster. We give you all the Helm charts and operators for that. So you could easily have these functions scale up. And what's cool with the functions, and I'll show you mine, is you could just, once you write this very simple function, you can point as many topics as you want to it. It'll do its functionality, and it can push it to whatever topic you configure. And then automatically any logs can go to a log topic. You can also, within your code, decide to route it. So you can have things routed to new topics on the fly or even create topics on demand, however you want to do that. And we have support for any of the libraries that these languages support. So if you want to run ML models, very easy way to do that. Now we do have a way to do that beyond just the Helm chart and operator. We've got something called function mesh that makes it easy for you to build and deploy these apps in a Kubernetes environment. It also lets you build up, a pipeline of these real-time streams, which can include things like sources and sinks and different functions along the way, and help you declare these with YAML, do a deploy, and have them all work together and scale up independently. Makes it pretty easy to do that. I won't go into the examples here, but it's a cool way to be able to run your applications, whether they're a mixture of Java, Python, and Go, and have them hit all these different sources and sinks, do different conversions, all that, have that hosted for you and scale up with Kubernetes pretty straightforward. And with full security, nice way to do this. We'll pass that. Now there's other connectors there. I just wanted to go on this one really quick. If you haven't seen Apache NiFi before, there's a drag and drop tool for moving data in real time. And there's some nice connectors there for Pulsar. So you can consume and produce the Pulsar by just setting a little bit of configuration. Again, more options, so you can code less. Just code the pieces that you really care about, not code everything. I'm going to show you a couple examples with Python. I've got them all documented here. I'll walk through them really quick before I jump into my live environment so you can see the real thing, so we're not just looking at 1,000 slides, but you'll get these slides, you can look back at it, and it points to all the GitHubs, so you can check those out. But I'll walk through a couple of these real quick before I go into the demo, just to give you an idea how simple it is. So the simplest thing is there's only one library you need for Python unless you're using the schemas. Connect to your cluster, connect to a topic, and you can start producing. Obviously, there's a lot more options depending on what you're doing. Support for dead letter queue, support for different logins, support for schemas. All add some to this, but just to show you the simplest way. When I'm connecting to, say, a cloud company like mine, very easy to do your OAuth authentication. Just put in a couple of variables and a URL, all going over SSL, and point to a file, and we're ready to connect. And then once you've done that, now you could just produce. Pretty straightforward. That's in the example code. So if you need to have security, which you should have, once you're running in the real world, it's not much harder than the example code that we showed you right here. We just add one more login and a file to connect to. Pretty straightforward. We want to add schemas, import our schemas, and then we could decide Avro schema or JSON. All you have to do in Python is create a simple record class and then put your field names in there. And if you have a schema already, it'll match up, make sure that they're the same. If you don't, Pulsar on this first message you put into it will upload a new schema to the schema registry and set that as the initial version. And then you could start producing messages there. And then the consumer of that data will get that schema from the registry, be able to unserialize it and just get data as records. They don't have to worry about manually parsing it or doing any kind of manual deciphering of these bytes that are being sent around. And the difference between Avro and JSON is pretty trivial. It just gives you multiple options there. And again, you could set a key. Key's helpful for debugging, deduplication, performance, logging, auditing. Very few reasons why you might not want one. Maybe your data doesn't lend itself well to a key. Maybe your data's, very little changes. and it's constantly just changing one value on and off. Maybe you don't have an ID then. If you've got anything that looks like a table, come up with an ID, even if you're just creating your own unique identifier there, just to have that for your own purposes there. Consuming, not much harder. Point to the server, point to a topic. Again, these can be dynamic. You could also subscribe to multiple topics, even with regex and wildcards. So you can pull down as many as you want. And if you don't have a schema, you could just grab the raw data out of it, which could be a string, could be raw bytes, depends on how you configure it, what you send it. Obviously, if you don't have a schema, then you're kind of making a jump of faith what that data is going to be, as it can be whatever that producer wants to send you if you don't have a schema. Now, if you want to connect with MQTT, you could just use the native libraries for that. In Python, it's Paho has a good one. And here I'm just taking some JSON, sending it as my payload, and just pushing it to a regular MQTT port. It just gets processed as MQTT until it makes it into Pulsar. I'll show you a couple different GitHubs. So when I start showing you the code, you'll know where it is. And I'll post these in the chat, and these are linked in the documents. But I've got a couple different ones. One to show an example function. One to show you how I'm pushing some data to some different places, including into Delta Lake. And then this air quality, which I show you all the potential ways to get data into Pulsar. I'm doing this with Spring. When we have our data running, I can look at it a couple different ways. If I'm using the cloud, I could use the cloud UI to take a look at the data. I could take a look at the schema that's stored in the schema registry. This one just has one version. I can see this one doesn't allow nulls, that sort of thing. If you're running the pure open source and you don't have a cloud hosting provider, you're doing it yourself, it comes with the Pulsar Manager, which is pretty strong way to look at what you have. You can see as many clusters as you have. You can see all the tenants, and the tenants are those different tenants underneath one cluster or a bunch of related clusters. And once you get under tenants, each tenant has its own namespace. So like here, there's a default one that sits under this tenant, and under there, I could see all the topics. This allows us to scale out to a lot of topics, which comes into play when you're doing work queues, plus maybe doing CDC on every table in your system. So typically, we have people put around 10,000 topics per namespace, because some people will have 1 million different topics, and it makes it a little difficult if you've got more than 10,000 under a particular namespace. That could affect performance. Though in the newest version, we have ways to improve that. But yeah, if you're going to have more than 10,000 topics, it's very hard to go through a list of 10,000 topics unless they're all similar named. So I recommend once you hit 10,000, create another namespace. You'd have tens of thousands of namespaces per tenant, thousands of tenants, make it as hierarchical as you can, makes it easier for you to discover topics, makes it easier to security on just what people need. So if you give someone access to just one namespace, you don't want to give them access to 100,000 topics. Maybe there's only a couple they need, and you may not want to have to set the security on each individual topic, but you do it at a namespace level, makes things a lot easier for everybody. I'm going to show you a Flink app, and we'll see how it auto deploys it while I'm running our SQL. Same for Spark. A nice feature of Pulsar that I didn't mention is there's a native connection for WebSockets. So in a simple JavaScript app, I could subscribe to data from Pulsar and get the data and display it in a live web page. I could also push data from the web into Pulsar over those same WebSockets if I choose. Makes a pretty easy way to get that data in and out. We mentioned NiFi. Here I have an example NiFi application that's bringing in some data, and then it's going to push it to Pulsar. Pretty easy. There's my topic. I have a connection to Pulsar. There's some specific options here. Here I'm setting my message ID, and it's pretty nice with NiFi because, again, that's all the code. The results of that, I can decide where I want to put them. Maybe I push that to a file system. There's errors. Maybe I'll send them somewhere else. Maybe I'll send an email, whatever makes sense here. As the data is being processed in NiFi, I get data provenance. This is the lineage of what's going on. Again, a great way to debug these systems, especially when the data could be coming from anywhere. And then your cluster could be running in who knows which different cloud, different availability zones. Here, I have a full lineage telling me what's going on, and I can push this into a permanent store if I want to analyze like what happened, what went wrong. You know, you have your full audit log here to tell me where this data came from, and I could even see that particular row, download it, and maybe push that into another data store. And here, this one is a different air quality reading, tells me what kind, gives me a location, that sort of thing. Pretty easy to do that for your data, and it runs pretty quickly. This is just on a very small node, but we're pushing through thousands of messages a second without a problem. Here I've got another little app in NiFi that's going to consume data as it comes off a IoT device I have. And let me get to that device here. We'll take a quick look at this Pulsar here. This is the Python code to send it. I'm grabbing some sensor data, and I set up this class to build my schema. That's all I have to do. I don't have to know about schemas. If you're an expert at Avro adjacent schemas and you want to just put them in there manually, you could. But all I have to do is create this class, give it types, say if it's required or not, and that is it. I have a schema now. This will be converted into the type that I want to send. So here I get my client. If it has authentication, I authenticate. I create a JSON schema from that record you saw, give it a producer name, give it an ID, and then I collect my sensor data, and then I push it over here and give it a key, and then it's just going to send that data over. Since it's connecting to my little local cluster, it's not doing all that authentication. If it did, it would add an extra hop there while it checks it, and then it would start producing it up here. I'm outputting it so you could see the data coming through. So I'm starting sending that to the thermal, and we'll see here the data starts showing up. And here I'm just sending it to alert if the humidity is above a certain amount. Again, being able to do SQL on live streaming data, nice feature here. We can see as that data is coming in, more is coming here, 8, 9's coming up. So it gives you a nice way to see what's going on, and all that data can be pushed to an auditing system so you know what's going on with your data. So we've got data coming in from this system for thermal, and I'm going to run my air quality data. This one is a little Java app that is sending the data not just to Pulsar via Pulsar, but it's going to send it also via Kafka, via MQTT, and via RabbitMQ here. So after it's sent the message, it's telling me that. I'm also caching this to a Scilla database just for doing min and maxes. But so each time this is going through, it's sending a different record into the system. And I can start looking at air quality and say Spark. So here I've created a Spark connection to my cluster for that air quality topic. And then I could see all the fields there. And then I could pop into my air quality and grab my Spark code here. And here, if I wanted to, I could write this to, say, CSV or JSON or Parquet or whatever format you want as that data comes in. Or I can push that right to Delta Lake. But for this one, I'm just going to take a look at the Spark data, just have it come to the console as those messages come in. So as new data gets pushed in, it's just going to come into Spark. Just another way you can write ETL or analytics on your data as it's coming in. I could put this in a Jupyter notebook or in, say, a Databricks notebook. Now for Spark, you could do something similar. So if I look at the air quality, I could also do things with Flink on aggregates. And what's unique with Flink is, besides being deployed out to as big a cluster as you need, this does SQL as events occur. So each time I send another message, if it's the max or if it meets these requirements, it's going to just continuously show up. And I can change this query. So instead of just displaying it, to do an insert. So I can insert into another topic, or I can insert into other Flink connectors. Flink has connectors to go into different databases, into different cloud storage. Again, the simplest would be to push it into another Pulsar topic and have someone listening on it to write an application or do something else. If we look in our dashboard for Flink, we could see that it's getting the data here from a source, doing a group by on it, and we could start looking behind the scenes what it's doing, how much data is coming in. Again, if we had a big Flink cluster, we could see this deployed potentially across hundreds or thousands of nodes. There are some large cloud companies in Asia that have made in-memory data warehouses that are Flink SQL against Pulsar, and the data only exists in Pulsar topics and in Flink cache, and those can grow to petabytes, but give back sub-second response, which is a nice feature, I think. So that's one example. As that data is coming in, it's just calculating it for different parameters. There's a couple other fields here. So I could see these is across different reporting areas. That's why you see it for different spots, depending on where that air sensor data was read. And we could do something like here, looking against certain values to look for trigger points. Since this is air quality data, get beyond a certain range, it gets dangerous to be outside. We should send an alert. So if you had subscribers, like if your company told your customers when it was dangerous to be outside, you could check against their region, look for a value, and as that reading comes in, you could instantly push out a message to someone to say, here's an alert, pops up in an app or sends an email or a text, however you want to communicate with people, and give them that information to know, hey, it's not safe to be outside anymore. And again, this is just an interactive way to run this SQL, do ad hoc queries, and get used to using it. Once you've figured out what your app is, and that's just a SQL, you could deploy it being wrapped with Java, Scala, or Python, and that could get deployed to the server and will just run there and run across as many nodes as you need to run against. Pretty straightforward. This has, we can't scroll back that far. There's a connection for Flink to Pulsar, and that gives me access to whatever tables and namespaces I gave it access to. So this is just looking at the public default one, and it gets access to all those topics as if they were tables. So it makes it pretty easy to for you to do this. And it has all the fields that are there, plus often some built-in behind-the-scene ones if you need it. And you can run, yeah, there's the catalog there. And again, if we had security, we would do that. This one is because these are JSON schemas. If we had different schemas, we would do it that way. But pretty straightforward to do this. And I've got a couple examples listed here. If you're interested in running against these tables, you could go to my example, Flink, and it'll show you how to do it. Pretty straightforward, though. Like here, you could just do regular, simple SQL if you don't have complex queries you want to do. At the front of this, I could insert into another topic from this as data comes in. This one is a simple query. So as events come in, it'll just start showing up. As you can see, if I had an insert, this would go into another topic or to another data store. Pretty straightforward. I don't know if I want to leave all of these running. Yeah, why not? Like, sure, I won't run out of space. But let's look at these here. We'll do the questions at the end because I said it's maybe complex to get the hands up and stuff later. But if you're on the Zoom remote, definitely put them in the chat. And then when it's time to go through that, I will take a look. But for now, hold them to the end, make it a little easier. Maybe there'll be no questions. This is pretty easy. As I mentioned, you could do WebSockets. Obviously, that's pretty easy from JavaScript. And I got the code out there, but you could also do WebSocket calls from Python and other languages. Pretty easy to do. And with this, I point to my Pulsar server. Pulsar by default has a REST API that's used for WebSockets. It's used for admin. It's used to show you what's going on in the system, lets you connect your different DevOps tools. So I can connect to that. And here I'm going to say I want to be a producer, and I'm going to connect to a certain tenant and namespace and topic. Something I didn't mention is that word persistent. 99% of the workloads people do in messaging are persistent, but they don't have to be. We can create a topic that's non-persistent. So if someone doesn't get the data, it just goes away. And that might be an acceptable use case for something like this that sends the same message 99.9% of the time, 1,000 times a second. Don't really need that. I'm just really looking in case something breaks. And if I get a failure condition or an alert, then I'm concerned with what's going on. The one difference when I'm sending data over WebSockets, I've got to encode it. I've got to ASCII encode it and then base64 encode it to be able to send it along with JSON. But as you can see here, that's pretty straightforward, whether that's done in JavaScript or Python or Java. Pretty easy. If you want to use the Kafka protocol to talk to Pulsar, there's libraries for it in different languages. Again, really easy regardless of the language you choose. I put a couple of functions out there. You saw the one for air quality that splits it up into 3 topics. I'll show you the source code, but I can also do the same thing for Python functions. And this is all I need to be able to deploy it. Pretty easy. Point to the source code, give it a name, give it the topics I want of input, where I want the logs, and if I have an output. This one I was using to do sentiment analysis, is I have a web page that sends messages into this chat topic, run a sentiment against it, and pushes out a chat result, and then have a WebSocket read it. Very straightforward to do that. This can also be wrapped in a REST call if you don't want to call the command line tools. Lots of different ways to automate this if you're a heavy DevOps team there. Functions are pretty easy, even easier in Python than in Java, as you might expect. Give it a class name. You got to put an init in there. Process is doing the major functionality. The one thing that you get here that's a little different is this context object. This is provided by Pulsar to give you access to logs, message ID, and lets you send messages to other topics. So if you want to do that, so it makes it, there's some good functionality in there. It also gives you access to a state store. So while you're running your functionality, maybe you could put, incrementing counters in there or values you might want shared between messages. Pretty easy to do that. And that's a key value store. You could do build apps in Go. I was impressed with the performance capabilities of Pulsar apps written in Go. The speed of producing data is pretty incredible. Go is a pretty nice language. There's also support for Rust, Kotlin, and a bunch of other ones. Nothing for Google's Carbon yet, because that's just came out a couple days ago. But someone will probably write that in the next few days. I've been looking at it. It doesn't look that hard since you can run C++ code, and we've got a C++ library. If you want to do things typed in Java, pretty easy to do it that way and have your schema be derived from your classes. Let me go into source code's all linked here. Let me get into the some more examples. I don't want to show 10,000 slides. I don't think they pay us per slide. Let me see if I can make this a little bigger. I know sometimes these show up tiny on the screen here. Hopefully that's a little better. This is an example function in Java. We derive it from function, and we pick in the key type that's coming in and the type going out. For this one, I am not sending anything out. So I'm doing void here. And I've got some hard codes I should put in a config file. But it makes it easier for me to understand showing you a demo. And these will be important because these are going to be where I'm going to send the data. So this is the only thing you need to have in your function. This is your main source of the data coming in and out. You could have as many other functions or methods as you need, connect to as many libraries you need, but you need to have this one to filter things out. Input is the data coming in. So here I'm checking to make sure I've got an input topic. I set my logger, output a couple things. Call library I have to convert this data into a format that I like. And then this is the majority of my code here is I look to see what was that key value that it sent me. And here it's PM25. If this is a PM25 air quality reading, I am going to send a new message to this particular topic. And I'm going to format that data with a JSON schema for this class, give it a unique ID, put a property in there because why not? And then put the value in there. And that's the value of a class that I created from those bytes. And I'm doing that for different types of sensor readings. If there were more, I could add more here. If I didn't want to send a message, I could not send a message. But that's as easy as it is to route data as it comes in to where it needs to go. Pretty easy to do that in a function. Now I have an example app that you saw run. This is the one that was building all that data. And that is pretty straightforward too. I get data from a REST endpoint. Pretty standard way to get data. Just iterate through it. Here I've got a service. I send it via Pulsar. I store it in my feature store just because why not? Then I also publish it via native MQTT, AMQP, and Kafka. So I'm sending it 4 different ways into the same Pulsar cluster. Pretty easy to do that, but it makes it just so if when you scale through the code, you can look and see, oh, okay, if I wanted to use AMQP, I could just use native AMQP. If I want to use native Kafka, I could use native Kafka. If I wanted to use native MQTT, I could use native MQTT. I don't have to use Pulsar to get my data into the system. This makes for, easy way to reuse code, and you don't have to learn Pulsar until you need to, which is nice. Now we went through an example of a function, pretty straightforward. I only touched on subscriptions. Subscriptions are important. That's how you connect your consumer to what data you want. You give it a unique name, and the server will track that for you. So it'll know where you are in that data as it comes in. So that's very important. We also have a lot of different ways to subscribe to the data, which is how we give you the ability to do different types of messaging. So say you want to have a work queue. I do subscription type shared, then multiple people can have that. So share that subscription, and we get the data as it comes in. Whoever gets it first gets it. And, if you want it to process faster, add more consumers. If you want things exactly once in order, you make your subscription type exclusive or failover. And then if you want something a little in between, we do key shared, where everyone can have their own subscription of that data based on a key. So only one consumer will give it for that particular key. That's a great way to do things like CDC, where I have a key being, say, the table name, and I keep that in exactly once order in the sequence I want. Lots of options. And what's nice is you don't always have to decide that before you start sending that data. Pretty easy way to do that. There's also timeouts. We could also send data synchronously or asynchronously and with built-in cache. So say you're pushing data in super fast, you could set a buffer of say 1,000 messages, and Pulsar will collect those and send them so you don't have to stop doing what you're doing, and it'll catch up as it processes it. Depends on your system. Usually TCP/IP is the only thing slowing us down from sending those messages, unless you are sending massively sized messages, because we do support pretty large messages. We have the ability to also break them up, and chunk them into pieces. So say you wanted to send, and someone asked me this in a class last week, what if I want to send a 20 gig object through Pulsar? I don't see why you want to do that, but they had a reason. It was a one-time move of data. They don't want to have to set up anything else. Pulsar had the encryption and the SSL and all the security they wanted. So using the chunking API, just turn on chunks and it'll just chunk that message into pieces. And then when it arrives on the other side, it's just reconstituted for you. That is an option. I didn't mention full encryption if you need that on, with different ways of different encryption algorithms, but all that's managed for you. So if you do want to encrypt your data, you just turn it on and it manages the keys for you. Or you could use your own encryption if you just want to encrypt your data when you send it. Because remember, we support raw bytes. So whatever you want to send, you could send it if you're not using schemas. We showed you Pulsar SQL, which is Presto. That's pretty straightforward, but it does give you some power to be able to look at your data without having to write any code. And this is the general format for doing that. And that's, again, we've got source code for that. Spark, a little trickier because you have a couple more options here and there's different ways to output that data. The Spark connector is now officially handled by the Apache Spark project, and that's an official connector on their site. Obviously, the Pulsar community helps them with it, but it is officially part of Spark. Same thing with Flink. If you haven't seen those projects before, they do have similar functionality. The difference being Flink is a native streaming, which means it does event at a time. Spark tends to do micro batches. On paper, it looks similar, but it tends to be in Spark. I handle data maybe every second or every 100 microseconds. Flink is the second an event arrives, I start processing it. It does it as events occur. There's no thought of batches. Batches is kind of artificial design of let me cache a bunch of messages together and then process that either at a number of message interval or at a time interval. And it's just a special use case of streaming. What's nice with Flink, it can do stateful processing. So if you need to manage data and know what that is over time while you're streaming, it can handle that state for you. And like I mentioned, that could even be up to the petabytes. Obviously, you're going to need a lot of big nodes if you do that, but it is a feature you can do. You do real-time ETL as things come in if you need to. You saw how simple it is to do SQL. It's a very full-fledged SQL. So if you need to do aggregates, combine things, there's all the basic SQL functionality in there to combine strings, do math, all those kind of fun things you like to do with SQL. Pretty similar way to connect to Flink as it is for Spark. We create a catalog, so I can join different catalogs. So I can have a catalog against Kafka, Pulsar, HBase, all different types of data stores and streaming systems, join the data together or read from one and push to another. Lots of interesting things you could do there. These are those example queries we were doing. Spark is pretty similar. If we need to monitor what's going on, there is full monitoring of every piece of the system, from topics to functions. You can see internal stats. All this can be done with command line tools and REST. We also push out all the metrics to Grafana and Prometheus, and we give you JMX feeds as well. So any way you want to look at the metrics, you could get them. As you saw, we get some of them in Pulsar Manager as well. And you can look at, you can also use the command line to consume data, check it out, do things like peek at messages without changing where someone is in their view, a way to like debug, see what's going on with things, see the amount of stats, how much data has gone through. Pretty straightforward. If you're doing a demo and you're done with something, you could just delete the whole system, you know, and then you could shut things down within Kubernetes or Docker. It is nice if you wanted to just run something for a short period of time. You could have DevOps bring up the system, create all your topics, namespaces, and tenants, push in your data, have it run, and when it's completed, clean everything up, shut down, and go away. And you can automate that on demand. Again, great for testing or different use cases there. We give you full access to the different metrics if you're interested to know what's going on, especially see how much data is getting pushed through, check to see if things are slowing down. Pulsar has built-in performance testing apps, so you can go to the command line and try to break things or see how much data you can push through in your environment before you actually try to do that with real data. So that's a nice a nice thing to know before you break things. Let me go through, need to see this. If you happen to be in San Francisco next month, we're having a pretty cool conference and we have a lot of our friends there. They're going to show us different ways to do some interesting things with Pulsar, and there's some new features coming out. So if you're around there, it'd be great to see you. I've got the discount code here. I got better discounts if you've got more people you want to attend. This will be the primary chair people from some major projects and some major companies showing you how they accomplished some pretty cool stuff with Pulsar. If we happen to have a sponsor on the line, I think we got room for like one or two more sponsors. I've got source code for every possible example you want in Java, in Python, running on Raspberry Pis, running on Jetson boxes, running in Kubernetes, Docker, whatever is interested to you. I work at Stream Native. We do hosting of Pulsar and Flink. We also do training. We also do free training. If you go to Academy Stream Native IO, I've got a bunch of free classes there. They also have dynamic labs with VS Code. We spin it up for you. You get your own environment and your own editor, and you can play around with it. Good way to try things out. Fun way to do it. We're now time for questions. I've been Tim Spann. If there's no questions, then I'll go into some other stuff, but I'm hoping we got a couple of questions in either person or on the virtual list I have there. We got like 9 minutes.
Any questions? None in the room.
Guess it's too easy. Should have put some hard stuff in there. I don't know what's hard for people, or is it everyone's too full from lunch? I don't know when they gave you the nice lunch there. If people ate lunch on the beach, I'm only a lot jealous. No questions in the chat either. That's weird, man. No one has any questions. It's just too easy.
We have one, Tim.
Oh, okay, that makes sense.
So, and you have a lot of people, I think a lot of people here where we are probably .NET developers, right? You have a lot of people switching their stacks, writing these things, these stream processors in other languages, or find people trying to jury rig something else in place. What do you do?
I got some of that. I didn't get all of that.
Yeah, check them out.
Yeah, we do have .NET support, and I've used it. It's pretty fast. It's nice. We do have native connectors for Azure, so you can get things in and out of Azure pretty easily. Trying to think what other ones that might be of interest there. Seeing which connectors we have. Oh, where's the Azure? Yeah, there's the C# one is good. There's also some weird clients for people who like exotic languages. There's some ones that aren't our mainstream supported ones. The Node.js one is solid, but some people have put them out there for Haskell and Rust, different languages. But yeah, C# works good. It's actually in the training as well. If you want to sign up for the free training, there is a course for C#, and you get to use C# to try out the environment. Enroll, it spins up an environment with a let's see if mine's still there. I don't know if I still have my environment. But it has a VS Code environment. So you get to use VS Code to do your editing, which should be pretty familiar for .NET people, and it's not bad. It's not a bad way to do that. And again, it's free training, and it's a nice way to give it a try. That way you don't have to install anything. But it gives a VS Code environment, spins up a little cluster, and connects them for you, so you don't have to worry about do you have permissions or all that.
Does the stream processing also support that, or is it just the
yeah, there is a Spark connector in C#. I haven't seen, I know Microsoft supports it. I haven't tried it with Pulsar, but it's supposed to support all the current Spark connections, so that should be there. Flink, I haven't heard of a C# connector. Yeah, I don't know if how far they got. That's 3 years ago. Yeah, I don't know if there's one for Flink. I know there's one for Spark, but again, yeah, with the C# one, yeah, you write your own code. Yeah, if you used Flink SQL, you could just use SQL. So you don't need to use any .NET code, and you could run that directly from an Azure link and have that run there, so you don't have to write any code. But there's not too many stream processing engines for .NET. I'm pretty sure there's Spark. That's where you get the ones that don't use, a language like Apache NiFi. This is a big project used again in Azure and against different Azure services. This one has got a lot of government users, so there's a pretty good support for connecting to different things in Azure. And again, since you're not writing code, so what's nice is you could write your code and say the C# to maybe that's how you're populating your data, and then have someone like NiFi do some other things for you. Then maybe Flink SQL just running SQL doing some, gives you some different options so you don't have to write code for everything. But yeah, when you need to interact with the code, you could have the C# library, pull it out of Pulsar. What happens between, these steps here? This side could be a C# app. Stuff happens elsewhere that doesn't involve code and could run in Azure or on premise. And then on the other side, you could have another C# app. These could be any language you want in there. It doesn't matter. Whatever app you have over there, or when it gets into a data store of your choosing, then you could have your app run it. Whatever makes sense. And again, with that support for WebSockets and REST, pretty easy to do those from C#. Yes, you look at the GitHub. I have done a bunch of IoT sensors, and it's pretty easy to do that. And now that you could get .NET Core running on there, you could use the C# one to do that too. My examples are mostly Python, but it would be possible to do that in C# if you wanted to use that for IoT. What's nice is MQTT is probably the protocol you want to use, especially if you're using some of the stuff from Adafruit. That tends to be a protocol they support. Get that into your little Pulsar that's running on a small laptop. And, you know, you could have a lot of processing there. And you could have that host in Azure. Depends what you're doing. But we got 2 minutes left. Let me make sure you have that link in there. And there's a lot of other ones in there. They're all Apache licensed. Do what you want with them, fork them, take them. Just open source examples and different apps out there. A couple different languages. What else might be useful? Let me post the class here. And I think we are almost out of time. I'm guessing the people sitting in the seats can't see that, but I'll make sure we have all the links in the slides, and I'll make sure those are distributed and we get them there. I'll see how I can post them online here. Otherwise, I'll tweet it out, make sure everyone sees it. Thanks for everyone attending. I think we got 1 minute. I'm going to make sure I have this downloaded, and I'll post this right after we're out of here. Thanks for attending. Hopefully you saw something of interest. If not, I was somebody else. Thank you.